It was around the year 460 BC when the Greek philosopher Democritus first wondered, if you break a piece of matter in half and then break it in half again, how many breaks will you have to make before you can break it no further? That's essentially the most basic definition of the atom. Physicist J.J. Thomson first modeled the atom in 1906, and he called his final product the plum pudding model. In this model, the plums are electrons, which are scattered randomly throughout the particle. The pudding goo represented a relatively large positively charged space that was supposed to account for the atom's neutral charge. This was the model that people accepted for a few years, and then one of Thomson's old students, Ernest Rutherford, discovered something new. Rutherford had a pair of his own students, Hans Geiger and Ernest Marsden, perform an experiment in which alpha particles, which we now know are essentially positively charged helium atoms, were fired from a particle emitter into an extremely thin strip of gold foil surrounded by a ring of zinc sulfide, which would emit a flash if an alpha particle collided with it. They expected the particles to pass straight through the foil, but when they began the test, they noticed that a small number of the particles were veering off course, and some of them even bounced back off the foil. Rutherford deduced a few things from these observations. Since most of the particles did pass straight through, a large part of the atom was empty space, so Thomson was right about that much anyway. For an atom to bounce off another atom, however, there had to be more than just electrons in positively charged space. There must be a relatively massive component somewhere amongst the electrons, which themselves have a very low mass. Also, we found that if the massive body was positively charged, it could explain why the particles were veering to the left and right of their original path. We know that like charges repel, so if the mass in the middle of each atom was positively charged, particles that passed close by each other would push away, causing the alpha particle to be deflected. Rutherford developed his model of an atom that consisted of electrons orbiting a positively charged central mass. This central mass was called the nucleus. He also proposed that within the nucleus there were two components, the positively charged proton and the neutron, which held no charge. His model became known as the planetary model of the atom. This idea was expanded on by Niels Bohr, who in 1913 created the familiar Bohr-Rutherford model of an atom. This model held a similar structure but saw the addition of electrons orbiting a nucleus in organized orbitals with a limited number of electrons in each shell. We now know that this model isn't 100% correct either, but the idea of the nucleus and orbiting electrons holds true to this day, so it is helpful in understanding the electron cloud model that we now study. So while Rutherford wasn't dead on in his understanding, he was a major contributor to our knowledge of the basic components and structure of the atom.